Emostel.
Hello, this is Emmanuel Kadri and you are welcome to this video. This is our second video on the topic logarithms. Alright, in the first video we just introduced you to the basic concept of logarithms and then the laws, and we did a few examples to just verify those laws. Okay, now in this video we are going to be applying the laws of logarithm to solve some kind of questions. Okay, alright, so enjoy the ride. The first question here is log 100 plus log 1000. All right, so in this law, in this question, I do not want you to make the mistake of thinking you could reverse the addition law of the product law of logarithm. Remember, the product law of logarithm says, let's say log a x, all right, y, log a x y is equal to log a x plus log x a to base a plus log y to base a. All right. So, which means log xy to base a is equal to log x to base a plus log y to base a. So don't think you can, when you have this one now, like this is a common, this one now is a common log, okay? Like log x to base a, both of them have a common base, okay? All right, so in this case now, right, you could reverse the whole process. You could make this one to be equal to this if the condition warrants it, or if the situation of things needs you to do that. It is very much allowed. For instance, this is to base 10 to base 10. You could, since they have the same base, yes, you could reverse the law, okay? Which means you could make it this to become this, all right? So I'm going to solve this question in two ways. Way number one is to reverse it, okay? And way number two is to solve them separately and add the results, okay? So now, way number one is, let me just do the reversal of this law. That is, since they have a common base, all right? So let me just make, it's now as if we have this side here. So I want to change this to this side. So method one, assuming they were not of the same base, we will not be able to reverse it. But since they are the same base, we can reverse it to the product. So which means method one is to reverse it. That is, apply the product rule. Okay, to apply the product rule now, we are going to have common base, common logarithm, and then this one will be 100 multiplied by 1000, which means we are converting this to become this product law. Okay, so we brought this one into a single logarithm, and then 100 and this, okay, multiply. All right, so as we have it this way, then we're going to be having log, that is 100 multiplied by 1000, okay, is going to give us 100,000. So now 100,000 is the same thing as log 10 raised to power 1, 2, 3, 4, 5, log 10 raised to power 5. So log 10 raised to power 5, according to the power rule, okay, the power rule says that the power will go and multiply the logarithm. So we have 5 log 10, and then 5 log 10, okay, you know, I told you that if you do not see any number here, it is the same thing as it is carrying a base 10. If you do not see anything here, it means that it is to base 10. But if it is to another base, the base must be written, okay? But as nothing is written here, it means it is to base 10. So as it is base 10, we have the logarithm of a number that is the same thing as the base is equal to what? 1. So at the end of the day, we have 5 times 1, because this log 10 changes to 1, and then the answer is 5. So which means logarithm of 10 plus logarithm of 1000, the result is 5. Okay, so if you want to use method 2, method 2 to solve this problem is to split it, okay? So we say log 10, we convert this one to 10 raised to power 2, okay? That is 100 is the same thing as 10 raised to power 2. Or simply just count the number of zeros, then that is the power. All right, then plus log 1000. 1000 will give us 10 raised to power 3. We have 3 zeros, that's 10 times 10 times 10. And then at the end of everything, okay, so we have 2 log 10 according to the power rule. Then this one will become plus, this plus here, bring it down, then 3 log 10. As you know, log 10 is equal to 1. So we have 2 times 1 plus 3 times 1. Finally, 2 times 1 is 2 plus 3, and then the result is 5. So either ways, regardless of the method you apply, you're always going to get the same answer in as much as you did what is right. Okay, so that is it for question number 1. Check. We move on quickly to question number 2. You may pause this video, check what I did, practice it, and then move on. So don't think you could reverse the product rule if the bases are different. But because they have a common base, so we could use that reversal, and it actually as well worked for us. Okay, now let's quickly go to the next one. The next one says log 2, 16 minus log 2, 4. And then log 2, 16, right? We could also apply that law. So let's do method 1. We apply the quotient rule. The quotient rule for this says that log x divided by y, okay, to base a is equal to log x to base a minus log y to base a. Okay, so we might want to reverse the law to get back a quotient. So reversing the law to get back a quotient will give us something like log to base 2, okay, common base to base 2, since they are the same base, to base 2, then you have 16 divided by 4. The first number comes up, then the second one goes down. Please, that order of arrangement is extremely important. The first one is up, the second one is down. Don't do it the other way around, you get the wrong answer. Okay, so then we now have what? Log 2, 16 divided by 4 is 4. Then, okay, so we now have log, I'm calling the base before this, which is wrong. You call the number before the base. You say log 4 to base 2. All right, so we change this 4 to 2 raised power 2. 2 raised power 2. So changing 4 to 2 raised power 2, we apply the power rule. The power rule means this one will go and multiply the logarithm. So we have 2 log 2 to base 2. And then at the end of everything, since they are the same, since the number is the same as the base, the result is what? 1. Okay, so final answer 2. Okay, if you don't want to do that, if you want to use another method is to solve them separately. So you convert log 2, 16, you make it to become log 16 to base 2. You make it become log 2 raised power 4, because 16 is the same thing as 2 raised power 4. That is 2 times 2 times 2 times 2 in 4 places. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So instead of writing 16, you have 2 raised power 4. So having 2 raised power 4, you have minus log 2 raised power 2 to base 2. To base 2. Okay? So having that in place, you put this one here, that's 4, because the aim of actually changing this one to power of 2 is to have a number that is equal with the base, so that it can resolve to 1. Okay, it can simplify to 1. So that's just the aim of changing the power to something of 2. Okay, so bringing it down here, we have 4 log 2 to base 2 minus 2 log 2 to base 2. All right, so the same base as the logarithm, the same base, logarithm of a number that has the same base as the number, same base as the number, so that will resolve to 1. So we have 4 times 1 minus 2 times 1. 4 times 1 is 4, 2 times 1 is 2. So 4 minus 2 is 2. So we still got the same answer regardless of the method of approach. Okay, so that's that for the other one. Okay, so let's quickly solve question 3 here. Question 3 says, find the logarithm of 25 raised to power 4 to base 5. No problem. So what we do here is to first get rid of the power to give us 4 log 25 to base 5. So having done that, we try to make the two of them be the same. So we continue by saying 4 log, instead of 25, we write 5 raised to power 2, okay, then to base 5. So we send this guy to the other side too. So sending it to the other side, we know we had a 4 there before. Then we now have 2 log 5, all right, then to base 5. So this 2 here is as a result of the power law. The power law which makes 2 to come here to multiply log 5. Okay, so now then this 4 is the 4 that was here before. We will only have to put the brackets to separate them, so we just don't get things mixed up. Now 4 times 2 will give us 8. So we now have 8 log 5 to base 5. So, and since they are the same, okay, then that will be 1. And at the end of the day, the final answer is 8. Okay, so the final answer is 8 for that question number 3. All right, quickly, we move on to question number 4. For question number 4, we have it this way. Let me just quickly take this off. All right, good. So for question 4 says, question 4 is very tricky anyway, but it's so simple. So the question is, how do we simplify this? How do we solve something like this? Log 1 to base 3, okay? So what do we do? Well, it's very cheap. Anytime you see something like this, log 1 to base anything, the answer is simply 0, regardless of the base. Okay, let me just prove it to you. All right, we can easily change this 1 to log 3 raised to power 0, because according to the law of indices, any number raised to power 0, any number raised to power 0, the answer is always 1. It's always 1. So instead of writing 1 here, we'd rather change it to 3 raised to power 0. Reason why we chose 3 out of all numbers is for us to have something that is the same thing as the base, so that we can easily simplify it to 1. That's the trick, okay? All right, so in that case, we just take this one there. That is 0 log 3 to base 3. So since they are the same, the number and the base is the same, the results, the logarithm will be equal to 1. So which means we have 0 times 1. And 0 multiplied by any number is simply 0. So just in case of another time, no matter what the base is, the logarithm of 1 is always what? Is 0. No matter what the base is, it's always 0. So just have that at the back of your mind. Okay, now let's quickly solve for the last one. This says log 49 to base 7 plus log 1 to base 7. So based on what we have here, we already know that this one is going to be equal to 0. But don't let us just fast forward to that. Let's just play a little bit with it, which means we might choose to solve this question in two different ways. Okay, the method one is to apply the product rule since they have the same base. Okay, so we can apply the product rule to say, okay, product rule, applying product rule since they are adding, you do product rule. So we have common logarithm to base 7 of 49 multiplied by 1. So plus we mean multiplication, but we have a common log now, all right? Then we have this 49 multiplying 1. Then in that case, so we have logarithm to base 7 of what? 49. And 49, mathematically, 49 means 7 raised to power 2, right? So you now have logarithm of 7 raised to power 2 to base 7. So according to law of logarithm, this 2 goes to multiply the logarithm. So we have 2, then 7, 7. So at the end of the day, we have 2 times 1 because if the number is the same as the base, then the answer is 2. All right? So, but if you do not want to solve it this way, another way you could have done it is just to have this one as logarithm of 49 to base 7 plus logarithm of 1 to base 7. So I told you that logarithm of 1 is always 0. So you have logarithm of 49 to base 7 plus 0. No problem. So at the end, it simplifies to logarithm of 49 to base 7, right? So logarithm of 49 to base 7 will mean logarithm of 7 raised to power 2 to base 7, because 7 raised to power 2 is 49. 7 times 7 is 49. Then you apply the power rule. It becomes 2 log 7, 7, right? At the end of the day, it becomes 2 times 1. Then final answer is 2. So regardless of the method you use, you still get the same answer. You just need to be very familiar with the rules, and then you are good to go. All right, so I have separated this into some basic examples. Then the next video, we try to go into some more advanced examples to see how we can apply the rules of logarithm to solve some technical questions involving logarithms. All right, so I believe that you understood this video so well. If you do not get any part of it, you can always contact us and then reach out to us and then for further explanation on this, or to just share your difficulty so we can be able to tell you where you got it wrong or where you didn't get it right, or clarify further to you. Okay, so if you like this video, please just drop a thumbs up, and then please kindly share this video with as many people as possible who would find this useful. And then don't forget to follow Emostel Academy on all social media, the same name at Emostel Academy, on YouTube, on Twitter, which is X now, and then on other social media platforms too. We still maintain the same Emostel Academy. Subscribe to this channel so that you can always get an update. Subscribe and also activate the notification bell to all, so that as soon as you drop any video, you get updated. All right, see you in the next video. Bye for now.